Hi everyone, I am Savitha Mary, Assistant Professor of Mathematics, working in St. Joseph College of Arts and Science, Kadalur. In this video, I am going to discuss about the topic bounded and bounded above, bounded below, least upper bound, greatest lower bound, and finally least upper bound axiom. These are the definitions here we are going to discuss. See, bounded. Bounded is nothing but it satisfies both the conditions of bounded above and bounded below. And bounded above, see the definition, the subset A contained in R, which is A is a subset of R, is said to be bounded above if there is a number n belongs to R such that x less than or equal to n for every x belongs to A. So, here R represent the real number, and here every number, that is every element of A should be less than the number n. Every element of A, that is x represent every element of A should be less than the number n, then set A is called bounded above, and the number n is called least upper bound for A. The number n is called least upper bound for the set A. See the next definition, bounded below. The set A contained in R, the subset of R is said to be bounded below. There exists a number m belongs to R such that x greater than or equal to m for every x belongs to A. That means every element of A should be greater than the number m. Every element of A should be greater than the number m. Is called bounded below. So, and then the number m is called the upper. The number m is called a lower bound. Okay, so the number m is called a lower bound, and comparing the definitions, so x less than or equal to n is called bounded above, and the number n is called lower bound, and x greater than or equal to m is an upper bound. And see the examples. So, first example, integer, negative integers. So, -1, -2, -3, etc. And here the bound, here -1 is the maximum value, and it's reducing, the value is going to the minimum terms. So, which is and maximum value, so the region is bounded above and it is not bounded below. So, here see that, so -1 is bounded above, means upper bound, and it is not bounded below. And the positive integer, the minimum value is 1, there is a maximum value is not existing in the region. So, minimum value is 1, that means it is bounded below, and the lower bound is 1. Here the lower bound is 1, here the upper bound is -1. And see so the number n and m not necessarily in the region. Okay, so the bounded lower bound or the upper bound not necessarily be the region A, there is the set A. Okay, see the line segment, this is positive integer, negative integer, which is an upper bound, this is an lower bound. And see 0, 1 is a closed interval. 0, 1 is a closed interval. Here upper bound is 1 and lower bound is 0, and the interval 0, 1 is bounded interval. So, it is bounded because it is bounded above and also bounded below, therefore, it is bounded. See the definition, least upper bound. Consider the subset A of R is bounded above. Then if we say a number n is a least upper bound for the set A, it should satisfy two conditions. One is n is an upper bound. N is an upper bound for A, and the second condition, no number is smaller than the number n, smaller than the number n, then we call n is the least upper bound, least upper bound for A. And the next definition is greatest lower bound. Similar way, consider a set which is a subset of R is bounded below, and then it has a lower bound, we know that. So anyway, it should satisfy the two conditions like that way. M, there exists a number m such that m is a lower bound, m is a lower bound for A, and no other number, okay, so no other number is greater no other number is greater than the number m, then we call the greatest lower bound for the set A is m. Okay. Here I am going to show you an example. Set B is equal to 1 by 2, 3 by 4, 5 by 6, so on, 2 power n minus 1 divided by 2 power n, etc. Here the greatest lower bound is 1 by 2 and the least upper bound is 1. Since, and see the nth term, 2 power n minus 1 divided by 2 power n. In solving this, you will have 1 minus of 1 by 2 power n divided by 2 power n. In cancelling the value, you will have 1 minus 1 by 2 power n. So when n approaches to infinity, we have the value 1. So when approaches to infinity, we have the end of the value is 1, that is an upper bound for the set. So we call that is a least upper bound for the set 1. Here the lower bound is inside the inside the region, and the upper bound is not inside the region. Okay, it is not mentioned in the region. And then consider another interval. There is an open interval, and here see 0, 1, 2, 3, 4. Here the open interval represents only the elements which is greater value of 3 and the minimum value of 4. So not the value of 3 and 4. So here we say 3 is an lower bound and greatest lower bound, and 4 least upper bound, but both the values are not in the region. Okay, so the upper bound and lower bound and need not to be in the region. Okay, and next I am going to show you one definition. Least upper bound axiom. Least upper bound axiom. Consider consider the subset A, which is a non-empty subset in R that is bounded above. It is bounded above. Then A has a least upper bound. Then A has a least upper bound. This is and least upper bound axiom. Thank you. We will see in the next video. Thank you everyone.